Hey y'all, my name's Sam and I'm a chemistry and AP chemistry tutor here on Wyzant. Today, we're supposed to find out how many moles of water are produced when 3.5 moles of propane combusts. So we got a lot of nice hints in here. We've got combusts, we're gonna have to deal with propane, and then we're also kind of lucky because we have moles of water and moles of propane. So we should be grateful for that part and I'll explain in a minute. So first of all, we're gonna have to write a balanced equation, and then we're going to use that balanced equation to do our dimensional analysis or our different conversions, and then those are correct. So for a balanced combustion reaction, I remember that combustion fuel, which in this case is propane. Propane means that there are three carbons. Then we're actually fueling it with oxygen that's just in the air. So this is gaseous diatomic oxygen. A lot of students will forget this O2, so be really careful and remember that it's always O2 in nature. And it produces carbon dioxide, which I remember as being one of the biggest drivers of global warming because it contributes to greenhouse gases, unfortunately. And then also water, usually water vapor. Awesome. So let's make sure we balance this equation to make sure we have the correct molar ratios. So it looks like that 1 mole of propane contains 3 carbons. And in my products, I'm also going to need to maintain the 3 carbons. I can do that by putting a 3 in front of my product. I also have 8 hydrogens over here, and I only have 2 currently, so let me multiply it by 4. I always deal with oxygen last in combustion because it shows up not only in one species on each side of the arrow, but actually in 2 on this side and 1 over here, so it's kind of a mess. We've got 3 times 2 oxygens is 6, plus 4 is 10. I need 10 over here, so be careful and put a 5 because remember it's diatomic. Although the oxygen isn't really important for this question, just in general, it's good to practice. Perfect. Cool. Dimensional analysis. We're going from moles of propane in our given, and then we're going to need to convert it to moles of water. So I put my moles of propane, and I'm going to multiply it by a conversion. And I choose it very strategically. This way, I'm making sure that the moles of propane will actually end up canceling out. But the quantities are going to end up, working to my advantage to give me the correct number of moles of water. So when I do this calculation, I get 14 moles of water. And the last step is to make sure the sig figs are correct. And I think they are because they gave us 2 sig figs here, and we do a bunch of multiplication and division here, which means we need 2 sig figs as well in our answer. So I think it should be 14 moles of water. You're good to go. Thanks so much.